So you just had a chance to watch a video on fireworks, and it's not the first time you've ever seen a firework, maybe, hopefully. But when you start having a chance to look through this book, there's investigations that are kind of like the chapter. So this chapter is on atomic structure. And then each chapter or investigation is broken apart into little, what they call experiences. So think about the experiences as being like each section of the chapter. And by the end of this, we're going to hopefully get some more insight on fireworks and how fireworks work and how they give off their different colors. So here we're just going to kind of think about fireworks. And this first question was a cross-cutting concept. That's the CCC. And so we're going to think about matter and energy when we apply that to fireworks. So obviously fireworks come in many colors, and there are colors shown in this picture. How do you think the matter and energy of fireworks of different colors are similar and different? And so you will eventually have a workbook, and you'll be able to write your answers in this workbook. And for now, since we don't have the workbooks, maybe you just kind of grabbed a piece of paper or just a regular notebook and kind of jotted down some thoughts. And so when it says, how do you think the matter, let's talk matter, of different colors of fireworks is the same and different? And so matter is anything that has mass and takes up space. So when I think about like holding a firework in my hand, like not lit, obviously, but like, is there something different about the materials that are used to make the fireworks show different colors? Are there things about the physical composition of the firework that's the same? I mean, obviously they might all make the same shape, but then how come some of them make the same shape that's green and some make the same shape in the sky and it's red? Does that have anything to do about like the physical makeup of the firework? Then they talk about energy. How do you think the energy of fireworks of different colors are similar and different? And so energy, I mean, obviously energy is being released no matter what color of fireworks we see. We call that exothermic, right? It's some kind of a change where energy is released. And I see that in the form of light. We maybe feel that in the form of heat, although hopefully we're not like directly feeling the heat from a firework like in your hand or anything. That would not be safe. They're like crazy hot. And so yeah, I mean, there's obviously energy being released no matter what color of firework we're seeing. But then like what might be different about the energy being released? Is there a different amount of energy released when a red firework forms versus a purple or a green firework? And so this question is just to get you thinking. There's not necessarily a right or wrong answer. It's just, what do you think is similar? What do you think is different about the matter of different fireworks and the energy of fireworks that produces different colors? The second question, SEP, stands for Science and Engineering Practice. So this is like what scientists do. Scientists construct an explanation. And when they have an observation that, gosh, there's something different about the matter and the energy of these different colors of fireworks, they have to try to think of an explanation. And so here, number 2, it says, neon signs, such as open signs, use electricity and give off light continuously when they're turned on. What similarities and differences can you identify between neon signs and fireworks? And so obviously, again, like they're both giving off energy. Like they're both giving off energy in the form of light, maybe heat. I mean, certain lights, if I like feel the outside of a light bulb, they might feel warm. But then what differences are there? And so maybe you said something about, yeah, as long as the light's plugged in, as long as there's an energy source, a neon sign will continuously give off light. But the firework seems to give off light and then it's just done. Like it doesn't continuously light off the sky. That'd be kind of cool if it did. Maybe you thought of some other ideas, which is great too. What might be happening at the atomic level to explain these differences? Yikes! And so here's where, I mean, in a former life, you've taken science classes and you've heard about atoms, and maybe you even know that not only are they little tiny particles that make up matter, but atoms also have protons, neutrons, electrons, and they've got this nucleus in the middle, and then the electrons fly around the nucleus, and maybe you were told they fly around in these rings or shells or something like that. Based on your prior knowledge of atoms, do you think that there's like something different that's happening like to the atoms that make up this matter? I mean, like neon is an element, it's on the periodic table, so like atoms of neon gas, like what's happening to them in a tube so that they like, give off energy? Like what happens to these atoms when I like plug in the lamp or the light or whatever? What is the electricity doing to the atoms that's causing the light to be released? And maybe kind of along the same lines, I mean, I can hold on to a firework, and as long as I don't light it, the firework doesn't go off and it's not producing any light or heat or energy or any of that. So what's happening to the atoms of the material inside a firework when I do light it? So we need that outside source of energy, which in the case of a sign is electricity, or in the case of a firework, it's probably a lighter or something that you're using to light a spark, and then eventually the wick goes down and burns and ignites the firework material. Like, what do you think is maybe different about those two? That the neon light seems to continuously glow, but firework seems to give off its light and then stop glowing. And so again, there's not necessarily a right or a wrong answer here. We're just trying to start thinking about why fireworks give off light, why they're different colors, and eventually throughout this investigation, which is like a unit, we'll hopefully gain some answers to that.